Hey guys, it's Teresa here with the Intentional Classroom and Cosmetology Exam Review. I know it's been a hot minute since I've actually released a video, and that's really because I've been working like crazy on Cosmetology Exam Review, the program. So, I've been building all these videos for you guys and just getting them out there, but I've also been creating a testing resource for you to study for your state exam, which will include 8 modules focusing on all of the different topics you need to know with tons of practice test questions and practice materials. So I'm working really hard on that. We're almost there. But in the meantime, I am really excited to offer you over the next 3 weeks the Chemistry of Cosmetology Part 1, 2, and 3. I have done some chemistry videos in the past and they are important, but I thought I would try a different way to present it this time. I spent the weekend with a bunch of Cosmo educators, and this is always something that's so difficult for us to teach. And so I thought this could be a better tool. I could break it down differently, and maybe that's going to help you get through that part of your state exam. So here we go. Here we go. The Chemistry of Cosmetology, Part 1 is called You Matter, because you do matter, but also because, I think we're going to focus everything on matter. And I think it's one of the most important concepts when it comes to the chemistry of cosmetology. I should also warn you, there will be lots of puns involved here because there's just so many opportunities to do it. So if you don't like puns and ridiculousness, this might not be the video for you. So let's get it going. Just a reminder, if you have not subscribed to the Intentional Classroom on YouTube yet, please do it. Guys, this is how I reach you. This is how I tell the world what we're doing and how, better ways to teach and better ways to learn. And that's what we're trying to do. So make sure you're following us, you're subscribing. If you know any other people like you that are just interested in the science of cosmetology or the theory behind things, or if you just need more, go, share it, tell the world that we're doing it, go back, watch all of the videos that we have, because we really are trying to focus on all of the things that you will need to pass your state exam. If you watch all those videos and you still aren't sure if you're ready for that test, let me know. I do offer tutoring and I have hired other tutors to assist me in that. So we really have the resources you need to succeed. Okay. Enough of the pitch. Let's get to what we're doing, right? Part 1, learning objectives. This is what we're going to learn this week. We're going to start with dissecting matter and what it means to you as a cosmetologist. I mean, why does it even matter, right? I told you, pun central up in here today, okay? Next, we're going to explore the elements, atoms, and all the things that make us, because let's be real here, we are matter, right? Not only does matter matter, but we are matter. So we're going to talk about that part of it. And what is the element? What is an atom? What happens when we combine them? We're going to discuss the states of matter. Are you a solid, liquid, gas? Things that are kind of fundamental, but I think we need to review to make sure you're prepared for those questions on your exam. And finally, we're going to discuss the differences between physical characteristics and change versus chemical. Because as cosmetologists, as barbers, estheticians, whatever it might be that you are studying, we need to know the difference, because we are actually performing both types of services. We are doing things that create physical change, but we are also doing things that create chemical change. So we really have to understand the difference between them, okay? So what is matter? What is it? Okay, well, let's make it simple. Anything that takes up space. If it occupies space, that's it. If you can touch it, taste it, smell it, see it, it is likely matter. You're surrounded by it, you are it, okay? This does not include things like light and electricity. Those are examples of energy, and that is something we can talk about in a different electricity type chapter, which we will do at some point. But for now, my jam is chemistry, so that's what we're doing. Okay. Matter could be this tree here because it's spectacular, and who doesn't love a spectacular tree? But the tree itself is matter. It occupies space. It's there. You can touch it. You can see it. Guess you could taste it if you wanted to lick that tree. You do you, boo. Okay. So just do that. So that's a tree, right? A tree is matter. Matter could also be this wine, this red wine. I like a glass of red wine. I mean, I'm really more of a Sauvignon Blanc person, but my point is this liquid here is also matter. It's not just something you can pick up like my phone. It can also be something you can drink, okay? So just remember that it can be a liquid. Could also be a steam. So the steam from this geyser is actually matter as well. Okay, so anything that's in the air, you might not be able to see it. Ozone, oxygen, all of those things are matter. So even though I can't see the oxygen that I'm breathing in, it exists, it's there, and it is still matter. Okay. And finally, so is this squirrel in a dress. Now, I mean, that seems obvious, but how could I not use this photo when I found it? So we found a way to use this, okay? So the squirrel in a dress absolutely matter in case you were wondering, because I'm sure some of you were, somebody was, right? All right. So let's break down matter a little further. It starts with an element. An element is a pure substance. It is the absolute basic form of matter is element, okay? It cannot be broken down into something different. So if you have hydrogen, just one molecule or one atom of hydrogen, that is your basic element, okay? I feel like an element is kind of like a strong woman, right? You can't break them down. You cannot bring them down, right? That is what an element is. We are in our element. It is something in its simplest form, can't be broken down any further. There are 118 known elements that could be on a state exam, so I wanted to make sure you knew. We put all of those on something called a periodic table, which I'm sure you learned about in high school, maybe even middle school, right? We continue to find more, though we keep discovering different elements and different things. And, you know, that's why science is so amazing, because it's always evolving. There's always something new to learn. But elements, 118 known elements. And remember, this is something in its most simple form. It is a pure substance, okay? An element can then be broken down into an atom. Not an atom like the name, but an atom, A-T-O-M, okay? So an atom is actually the unit of matter. It is a basic measurement unit, okay? So an atom, here is an atom molecule or an atom next to you. I don't want to call it a molecule because we're going to get to that in a second, but here's an atom next to us. You can see it, okay? It's made of three things: electrons, neutrons, and protons, all right? What happens is in the center of the atom, you have your neutrons and your protons together hanging out. And then circling that, you have the electrons. Now, I always like to I'm all about the metaphor and the analogy. And so I think it's important that we recognize that I can do that here too. Okay. So I want you to picture a party. In the center of the room, you have your protons. These are your positive people that are like, yeah, let's have a good time. Woo, woo. And they're keeping the party going. They're super positive. Okay. With them, you usually have your neutrons, because that's maybe your neutral people. They're kind of quiet. They're not, the life of the party, but they're definitely having a good time. And they're hanging out with the protons in the middle of the party, which is actually the nucleus. On the outskirts of that, you have your electrons, and those are your negative people. Those are the mean girls that are, maybe not so nice to others, that are like, this party is the worst because they are negative, okay? So they're not involved in the party. They're just kind of standing on the outside judging the party, and that is the electron. So I want you to translate that into the composition of an atom. The nucleus is that proton and the neutrons hanging out together, the positive and then the neutral piece, right? And then on the perimeter is the electron circling it, always circling it, and those are the negatively charged particles, okay? So, if you've ever watched my videos, I will find any way to make some crazy analogy, and there you go, that's what you get for today. So think of an atom as like a single grain of sand, right? It's just one itty bitty singular piece of matter, okay? When two of those or more of those atoms come together, we make a molecule, okay? So a molecule, two or more of the same atom or different atoms put together to create a molecule. So I have a cute little picture of atom and atom since I made the reference earlier. I told you, full of puns, you are welcome, okay? There are two types of molecules out there. Remember, molecule, two or more atoms put together. An elemental molecule is two or more of the same type of atoms. So, ozone is O2, which means it's two atoms of oxygen put together. Now it's a molecule because it's got two of them there. And that's an elemental molecule, okay? Think atom and atom together forever, right? If those two stay together, they're the same, right? They are the same put together. There we go. Now we have an elemental molecule. Then you have a compound molecule, okay? This is two or more different types of atoms coming together, okay? This could be H2O2, which is hydrogen peroxide. This could be H2O, which is water, but it's two different types of elements, two different types of atoms brought together in a compound molecule, okay? These are things that you really need to know. You need to understand the difference between these two things, mostly because they're very likely to show up on a state exam. So make sure you know it for that information, if only that information, okay? All of this matter can come together in three different states. You have solids, you have liquids, and you have gas. A solid piece of matter has a fixed shape and a volume. So this lipstick right here, right, has a fixed shape. It is a solid piece of plastic right here, okay? Fixed shape and volume. Think a brush, a comb, a rock, right? If you pick up a rock, it's not like some amoeba's shape. It's not moving around. It's not like a jellyfish, right? It is fixed. It is going to stay the same shape. And unless we make it go through a physical change, it's going to stay the same volume as well. Okay. So that's our solid. Then we have a liquid. Okay. So a liquid still has a definite volume, but the shape is going to change according to what the liquid's in. So think shampoo, think some beer, think some water. You know, when you've got shampoo, it's the shape of the shampoo bottle when it's in there. But when you transfer it to your hand, it's a totally different shape, right? So liquids still matter, but definite shape, not a definite volume. Definite volume, no fixed shape. I apologize for getting that backwards just now, but definite volume, no fixed shape. It changes according to the container it's in, okay? Then we have a gas, and this gets a little trickier because there is no fixed volume, there is no fixed shape when something is a gas. Think about aerosol hairspray, right? It's in the can, and when you spray it, it doesn't it goes into a mist into the air. It's no longer in a fixed volume, fixed shape. It kind of goes into its own thing. And that's still matter. And I think we need to recognize that just because I can't hold it in my hand doesn't mean it's not matter, because a gas is absolutely still matter. So no fixed volume, no fixed shape. Think about aerosol spray, think about steam, something like that, okay? So what might your test ask you? They're going to look for things about the shape and the volume. So you need to remember that a solid has a fixed shape and volume, a liquid has a definite volume but no fixed shape, and that a gas doesn't have fixed anything, okay? Three forms of matter, you need to know them. All right, matter can change its state. I know, right? Because let's make things a little more confusing if we possibly can. But matter can change its state. It can go from water to ice to steam and back and forth. We need to understand what the characteristics are that we're changing and how we're changing them. Because as stylists, as barbers, as estheticians, as nail techs, we are performing physical and chemical changes for our clients. So we need to know what we're doing, okay? Let's start with physical, all right? A physical characteristic is something like color, odor, density, boiling point, melting point. It is something that we can physically usually see, and it doesn't require any chemical reaction to actually change it. For example, if you want to change the color of your house, all you have to do is paint it. You don't actually change the structure of the house. You just put a new color on it, right? If I want to paint my nails, right, I can put nail polish on this. I didn't physically change the structure of my nail. I just physically changed the color of it, right? There was no chemical reaction that made that happen, right? A physical change occurs when we change the physical appearance without a chemical reaction. Okay? Think painting your nails, putting on temporary color. And I threw that in there kind of to throw you off. But the reality is when we put temporary color on something, we're not getting into the hair strand to make any chemical change. We are simply coating the hair. When you put mascara on your eyelashes, you didn't actually go change the physical structure of the inside of your eyelash. You just coated the outside of it. And mascara is a temporary color. So just remember that. Same thing with ice melting, right? Ice, if you sit ice on the counter, it's going to melt on its own. It's not really going through a chemical reaction, because when it's all said and done, put it back in the freezer, it turns right back into ice. We didn't change it into something new. And that's why it's a physical change. We didn't change it into something new. We just kind of changed the look of something, okay? Now let's get into chemical change. And things get a little trickier with the chemical change, okay? A chemical characteristic is something that basically it's only changed because of a chemical reaction. And once it's been changed, you've created something completely new, okay? To witness or change them, we've got to use a chemical reaction. So, an example of that is rust. If you leave a piece of metal outside in the rain over and over again, eventually the metal actually chemically changes into rust. You can't put that rust in a pile, put it in the freezer and it turns back into metal. Like it's a totally new substance, okay? Same thing with oxidation and permanent hair color, right? Lightener, perfect example. When we put lightener or permanent color on the hair, it goes into the cortex. And what it actually does is breaks up the melanin, creates new molecules all together with the aniline derivative. I mean, there's so much going on there. It never goes back to its normal hair strand, right? So I use lightener as an example because when we use lightener, basically what we're doing is we're punching a bunch of holes into the hair. You can't just put new color back on it and it's back to its original state. It might appear that way, but inside it's a totally different structure. Like we have changed everything. When we do something like relaxers, right? Let relaxers go through the lanthionization process. We actually go in and completely change the structure of the hair. We break disulfide bonds, we remove sulfur atoms, and we create a totally new bond called the lanthionine bond, right? It chemically changed the structure of the hair. There's no going back. You can't just put it back together and be like, well, everything's fine now. That's not how that works, right? In a chemical change, we actually create something new, right? With a chemical reaction. So I like to use a cake for this because mostly I like cake a lot. That's like my second calling is to be a baker because I love to bake. When we bake, we start with eggs, flour, milk, oil. I mean, these would be all of your different elements that you're going to add into the cake, right? They're all separate. Put them all together in a bowl, we mix it together and we stick that baby in the oven. And after about 45 minutes, half hour, 45 minutes, depending on what you're baking, you get to eat something delicious, right? You get to pull a cake out of the oven. Well, chemical reaction has occurred inside, right? We've created something totally new and we can't just take it back apart afterwards. I can't take that cake and pull out the eggs and just eat the egg. I can't take that cake and pull out the butter and just chew on that stick of butter, which sounds delicious, but I can't do that. We've created something new with that cake. It's a totally new substance at this point, okay? That's a chemical change. That's a chemical reaction, okay? So that's what I got for part one of this. Let's review. Matter is anything that occupies space. An element is the basic form of matter, and its small unit of measurement is actually the atom. The atom is made of electrons, protons, and neutrons. Two atoms put together make a molecule. There are three forms of matter: solid, liquid, and gas, okay? And these forms can go through physical and or chemical changes, all right? Of course, there was more than that. That's a really brief overview. Go watch it again if you need to. But just remember, guys, this is stuff that you will absolutely have to know for your state exam. So next week, we will do part two, which is substances and mixtures. In a lot of my tutoring sessions, students mix this up all the time. They don't know the difference between miscible, immiscible, solvent, solute. They don't know the difference between a suspension and an emulsion and all of that stuff. So we're going to talk about that in next week's video. And then the week after that, we're going to do the pH scale, which is a killer because it's everywhere. It's in every bit of chemistry that we do as a stylist. And you really need to understand what it does and how they behave, because without that information, you could fry hair off. And that's really, I mean, I'm all about you passing your test, but I'm also all about you being a knowledgeable stylist that can manipulate hair without breaking it. So this all helps with that, okay? So thank you so much for watching, guys. Again, my name is Teresa Muley. We are the Intentional Classroom. We are a cosmetology exam review. Please subscribe to our channel, share with everybody you know, get everyone you know to subscribe, because I really am trying to pump out some content that's really gonna help you with your journey as a stylist, a barber, an esthetician, whatever it is, a nail tech, whatever you're doing in the beauty spa and wellness industry. And hey, even if you are a seasoned stylist who just needs a review, here you go. So subscribe, like, share, do all of the things. Thank you so much for watching us. I cannot wait to talk about solutions and solutes and all the things with you guys next week. Thank you so much. This was the Chemistry of Cosmetology Part 1. Have an awesome day.